So today we're learning about writing and graphing inequalities. If you recall, an inequality, it's not an equal sign, so it's when one side of an equation is either bigger or smaller than the other side, so that's why it's unequal. Some symbols that we use are less than, that's this symbol, looks like an L tilted a little bit, greater than, less than or equal to, greater than or equal to. Okay, so our essential question is, how can you use an inequality to describe a real-life statement? So first we're going to take a look at some of these real-life statements and try to see how can we represent them with an inequality. All right, so you'll see that there's 4 different ways that we'll write every inequality. Well, first there's just the regular inequality, okay? Then there's what we call set builder notation, interval notation, and finally by using a graph. So let's take a look at this very first situation. The temperature T in Sweden is at least negative 10 degrees Celsius. So it's telling us to use the variable t. So underneath inequality, I'm going to say t is at least. That means it could be more or equal to, so greater than or equal to negative 10. So it could be negative 10 or more. That's how we would write that inequality. Now, set builder notation uses these fancy brackets, curly brackets. You state the variable that you're focusing on. In this case, it's t. Then we use a vertical line. It's kind of like 1/2 of an absolute value, you know, one of the bars of an absolute value. And the way you read it is that line means such that. So all variables t such that t is greater than or equal to negative 10. So it's kind of very similar to the one we just wrote in orange for inequality. So that's set builder notation. Now interval notation means, so it's going to be, it looks like almost like a coordinate points. We're going to have one number to the left of a comma, one thing to the right of the comma. And I shouldn't say number because it could be a symbol that we'll see. And it depends on where it's going towards. So in this case, t are all values that are above negative 10. So it can keep going up, up, up into infinity. So on the right side, we're going to put an infinity symbol and parenthesis. On the left side, the farthest to the left we can go, the smallest number that we can have is negative 10. So that's going to be on the left of this. Now, since it's greater than or equal to, we can be equal to negative 10, and the way we represent that in interval notation is with a square bracket. So it's got right angles there. So we go square bracket, negative 10, comma, infinity, parenthesis. The parenthesis means you cannot land on that number, and since infinity is not a number but more of an idea, we use parenthesis. A parenthesis is 1/2 of a set of parentheses. Parentheses is 2 of them. Anyway, so you go parenthesis whenever you have a number that you cannot land on. All right, so how you would read this is from negative 10, including negative 10, all the way up to positive infinity, which goes on forever. All right, and then the graph. So you see some tick marks on this number line. Pick one of them. Usually pick one that's kind of in the middle, and that's going to be where my negative 10 is. That's going to be an important spot in this graph. And I'll graph a few more. So going up is negative 9, negative 8. Going down is negative 11, negative 12. Now, something special is happening at negative 10. That's our lowest value. And since we can equal negative 10, we'd be okay if the temperature was equal to negative 10. I'll put a filled in circle. And then I want everything that is above negative 10, so that's to the right. And it goes on forever in the positive direction, which is to the right. So it's going forever towards positive infinity. So I make a nice arrow going to the right. So those are 4 ways to represent all the values that are at least negative 10. All right, so now what are some of these values that we are okay with? So in this space, it says values that satisfy the situation. So some numbers that satisfy the situation, well, negative 10 satisfies it because negative 10 is at least negative 10. So would numbers like negative 5. Negative 5 is bigger than negative 10, so that would work. Also 0, and then any positive number, we can go 23. So those are all some examples that satisfy, that would make this equation, this inequality true. Now and you can also notice that all those numbers that I just listed would eventually be shaded on our graph. That red arrow would eventually get all of those. Now, in this other half, values that don't satisfy the situation, those are numbers that would not be shaded or that are not greater than or equal to negative 10. So in this case, that's numbers like negative 11, negative 28, even if we went negative 10.1. That's still too far to the left, not being shaded. All right, let's try another situation. So the elevation E of Alabama is at most 2,407 feet. So at most. So we're using the letter E for our variable, and the number 2,407. Now, the elevation is at most 2,407. So that means it can be lower than that or equal to that. So that means E is less than or equal to 2,407. So that's our inequality. In set builder notation, again, we get to use those fancy brackets, those curly brackets. Do the best that you can with that. If you just make a little squiggle line, that's okay. Anyway, then we are focusing on the variable E such that all values of E are less than or equal to 2,407. All right, so now, in this case, since we're less than, we're okay with things getting smaller and smaller and smaller forever. That means in my interval notation, I use negative infinity on the left side because that's the smallest you can get. Well, you can always keep going smaller. That's why we use negative infinity. Since you can't land on negative infinity, I use a parenthesis. Now, the largest value that we can have is going to go on the right, and that's 2,407. And since we can be, if we're equal to an elevation of 2,407, we're happy. Since we can land on 2,407, we'll use a square bracket there. For our graph, I'm going to do 2,407 in the middle here. And since this is a pretty big number, I don't have enough space to fit the 2,408. Let's go, then this would be 2,409. So I'll just show all the odd numbers here. Okay. So, I put a circle at 2,407. Since I can land on 2,407, I'm going to fill it in with a filled-in circle. And since it's less than, we go to the left towards the negatives and towards negative infinity. Going to the left. All right, let's talk about some values that work. Well, 2,407 works. So would 1,986 elevation. And so would negative elevations. You could have a negative 100 elevation, and you can keep going. Some values that don't work, well, 2,408, right? That would be too tall for Alabama, too high up. Also, if we want to be real more particular, 2,407 point, and let's go 0.08, right? That's still above 2,407, so that's too much. Also, you know, you can go ridiculous and say, well, hey, 15,000, that's too big too. So those are all values that do not satisfy the situation. All right. Oops. So this next one, the height h of every person who has ever lived is less than the tallest person who has ever lived, who was approximately 8 feet 11 inches tall. All right, so every person who has ever lived, other than the tallest guy, is what to the tallest guy? Well, they're all shorter, right? So the height h is going to be less than, and the way you can write 8 foot 11, 8 little 1 dash, 11 2 dashes. So nobody else can be equal to that height. So everybody else is less than that height. In set builder notation, just like we have been doing, curly bracket, h is our variable such that h is less than 8 foot 11 inches. With interval notation, so this is a less than situation, meaning it's going lower and lower and lower. That would be more like our B situation. So when you go to when it's less than, you're going to the left towards negative infinity, and whenever you have any type of infinity, you use a parenthesis next to it. On the right half of this interval notation, we'll use 8 foot 11 inches, but since in this case we do not want people who are equal to 8 foot 11, we only want people who are shorter than that or less than that, we cannot use a square bracket here. We have to use a parenthesis. So in this case, we have 2 parentheses because we cannot land on either one of those numbers. Well, negative infinity is more of an idea than a number. So, okay, next is graphing this. So find a spot right here. I'll say 8 foot 11 inches. And each one of these, let's make another inch. So getting shorter, that short guy, 8 foot 10, 8 foot 9, 8 foot 8, right? Those are really short heights. That's just a joke. Anyway, going up, we have 9 foot, right? 1 more inch above 8 foot 11 is 9 foot, and then 9 foot 1 inch. Okay, anyway. This time, we put a open circle, but we don't fill it in because that open circle represents that we cannot land on 8 foot 11. And we are shading to the left because we are going less than that number. There we go. Oop, connect my... Okay. Now, for values that satisfy the situation. All right, somebody who is 8 foot tall, 0 inches, that person would satisfy, that person was shorter than 8 foot 11. Even 8 foot 10 and a half, that would be okay. Even, I'm 5 foot 10, my height would satisfy the inequality. Values that don't satisfy, well, 9 foot doesn't work. 9 foot 0 inches, if you're 13 feet 6 inches, that wouldn't work either. Neither would 9 foot 7 3/4 inches. All right, those are all heights that would not work. I'm just coming up with some random numbers or heights that are above 8 foot 11. Okay. Oh, actually, another one that I'd like to bring up that doesn't work is 8 foot 11 itself, right? Because in this case, we don't want anything that's equal to 8 foot 11. So in this situation, 8 foot 11 also does not work because of that open circle. All right, and let's take a look at this one. The race times R of all runners in a 100-meter race are slower than the world record time of 9.58 seconds. Well, that makes sense, right? most races have people who are slower than the world record time. So we have R, and this is slower. So be careful. In a race, when you're timing it, slower actually means a bigger number, right? The more impressive times are the smaller numbers in a race. So when we say slower times, they're actually getting bigger. The numbers are, at least. So this would be R is greater than 9.58. And then in set builder notation, curly bracket, R is our variable such that R is greater than 9.58. Interval notation. So now we're going greater than. This is kind of similar to part A. Since it's greater, it's keep getting bigger and bigger and bigger. We can go to positive infinity. And we always use a parenthesis because you can't land on infinity. And then to the left, the smallest number is 9.58. But since we want all numbers that are bigger than that, we can't land on 9.58. Therefore, we use a parenthesis. All right. Graphing. Let's fit 9.58 in here in the middle-ish. And let's go every 100th up. So 9.59, 9.60, 9.61. Going down, 9.57, 9.56. Okay, we put an open circle at 9.58. We do not fill it in because we are not including the number 9.58, but we want everything above it, so we'll shade to the right. Like so. All right, so what are some values that satisfy this situation? Well, I coached middle school track. I remember some kids running times that are like 13 seconds, so 13.4 seconds in the 100-meter dash. That would satisfy this. If somebody ran 10.3 seconds, that would be a really fast high school time. For a boy, that would be satisfying this. Basically, any time that probably anybody in this room would run would satisfy, because more than likely you're not the fastest. So let's go, even 9.9 doesn't work. 9, oop, or does work, I should say. 9.59. That also works because that's slower. Now, sometimes that don't work. Well, 9.58 itself does not work because we're looking for ones that are bigger than that and anything less than that. So 7.8 seconds would not work. 3.44 seconds would not work, right? Those all are too fast. Okay, so next page we have all these different symbols that we've already reviewed, and there are certain keywords that you might hear to give you a clue to use those words. So we've got a few problems here, 1 through 6. Go ahead and try those out. If you want to pause the video to give them a shot, and then press play when you are ready to check your work. All right, so first off, we are writing the inequality that goes with the statement. It says include set builder notation and interval notation. Then decide if negative 11 is a solution of the inequality. So a number increased by 8 is less than negative 3. Well, we've got a number. Let's just call it n. Increased by 8. Well, that's adding 8. That's what increased by 8 means. That is less than negative 3. So, just like that. So there's our regular interval. If I wanted to write that in set builder notation, I'd use fancy brackets, n such that n plus 8 is less than negative 3. Just like so. We are not, let's actually not worry about interval notation. in this case. All right, we'll save that for a little later. Now, if we are going to decide if negative 11 is a solution, well, we can plug negative 11 in for the n. Okay, well, that would be negative 11 plus 8 less than negative 3. Well, negative 11 plus 8 is negative 3. And this is kind of a tricky one, so it looks like it works, but negative 3 is not less than itself, it's equal to itself. So this doesn't work, so actually negative 11 is not a solution, so no, not a solution. All right, let's try this next one. Negative 4 times a number is no less than negative 51. So negative 4 times a number, let's call it x this time, is no less than negative 51. So that means it could be more than or equal to, negative 51. Kind of froze there for a minute. Next is interval notation, set builder notation, fancy bracket, x values such that negative 4 times x is greater than or equal to negative 51. Let's check if negative 11 works here. Plug in negative 11 in for x. And is that greater than or equal to negative 51? Well, that is negative 4 times negative 11 is positive 44. And is positive 44 greater than or equal to negative 51? Well, yes, it is. It's quite a bit bigger. So yes, 11, or negative 11, is a solution here. Next, graphing. So we have b greater than 2. So pick a spot that's 2, label a few more, open circle at 2, and we are shading to the right because it's greater than. Greater than goes to the right. And open circle because it's just greater than, it's not greater than or equal to. All right, next one, negative 19 is a focus point. Getting bigger, be careful when you're labeling in the negatives. A bigger number actually means a smaller value when you're talking about negatives. So x is less than or equal to negative 19. That means we put a closed circle at negative 19 because we're including negative 19 as one of our answers, and then shading to the left because we're going less than. Okay, and maybe let's practice interval notation in this space. So in this case, with the b greater than 2, we would go from 2, not including it because of the open circle, and we're going towards positive infinity, and with infinity, we always use a parenthesis. For the negative 19 one, we're going from negative infinity, because it's going to the left forever, parenthesis because you can't land on negative infinity, and then the highest value is negative 19. We can land on that one because of the closed circle, so we use a square bracket. Numbers 5 and 6, or 5 is A and B. We are going to check if the value is a solution. So here's an equation, and it's saying, will this work when r is 5? Well, let's plug 5 in, so that'd be 3 times 5 plus 4. Is that less than 28? Well, that's 15 plus 4, and 15 plus 4 is 19. Is 19 less than 28? Yes, it is. Therefore, 5 can be a solution for r. Okay, over here, same kind of thing. Plug 3 in for m. That'd be 7 minus 3 greater than 8. 7 minus 3 is 4. Is 4 greater than 8? Well, no, it's not. So, no, m cannot equal 3. All right, and last ones here is we have ride A, ride B. They are showing the heights that you can be for the ride. we want to write an inequality that represents the height restriction of each ride. So write A. We'll let the letter A represent the height for ride A. And it's got a closed circle, and it's going to the right. Therefore, it's going to be greater than or equal to, and the number that we're focusing on is 48. So that's ride A. Ride B. B is, well, 52, looks like you have to be shorter than 52 inches. So that's less than, not or equal to, because of the open circle, and 52. All right. Next would be working on the homework for practice of this assignment.